Alright, this is Mr. Gillum, and today we're going to continue to prove triangles are congruent and different forms of the proofs and things like that. And we're going to add another postulate to our list. So we now have the side and the side angle side. And today we're going to learn about the angle side angle postulate. Alright, so some of the keywords you're going to make sure you need to know are the included. You know which one I'm referring to when I say included. And that's going to be really important because if we just have two random angles in a side, that might not always work. It might work. We might learn about that another day, but for now we need the angle and the side and the angle. Okay, it has to be the included side. So the postulate says this: instead of having to prove all of the angles congruent, all the angles and all the segments congruent, or we could prove just the segments congruent, side, or side and an angle and a side. Now you can prove triangles congruent through an angle, its included side, and another angle. So if the angle, the included side, and another angle are congruent to an angle, the included side, and another angle of another triangle, then those triangles are congruent. Okay, so the side between the congruent angles is the included side. So if these are the two congruent angles, the included side must be in between them. So we've also had a few different other types of postulates. The side as when we have these two triangles, and we knew that their sides, all three sides were congruent. And we also knew the side angle side. We learned this, where if we have a side and an angle and the next side over, then they're congruent. Now we have angle side angle. So angle included side angle. And so side angle side was the same way. We had a side, the included angle, and a side. So basically it's a side angle side postulate, but with angles. So angle side angle, that's what we're going to practice with today. So looking at this little proof here, this little proofy proof, because I know you love them. We're going to work on using our little angle side angle real quick, and just to get an idea of when it's appropriate to be used. We're going to write a two-column proof here, and it tells us that QS bisects angle PQR. So QS is bisecting PQR. Now that tells me when it says bisect that eventually any of these are going to be equal angles right here. That's the definition of an angle bisector. So I'm going to actually have to use that to prove. I'm going to have to say that down here in my proof, but I just want to remind myself that I know that through this. That way I can make a good choice on whether I'm using side angle side, or angle side angle. It also says that angle PSQ is congruent to angle RSQ. So it's also telling me, it tells me for sure that these little guys right here are equal. All right, so we got, oh, looky here, boys and girls. It looks like I have an angle, an included side, and another angle of these two triangles. So this is pointing, all flags or all arrows are pointing towards using the angle side angle postulate to prove that these triangles are equal. Now, it could ask us to prove that PQ is equal to, segment PQ is equal to segment RQ, or QS is equal to Q. It doesn't matter what it says. But basically all the proofs that we do this chapter, you'll eventually have to prove that triangles are congruent. If it says what's an angle and an angle that are congruent, you're trying to prove it, that just means you're going to have to use corresponding parts of congruent triangles are congruent. But for the most part, all of these, to get to where you're going, you'll need to prove that there are some triangle relationships that are congruent. Okay? All right, speech out of the way. Let's knock this out. First things first, we got the given. Okay? We got the given, and that's literally just right there. Okay? And that's the given information. Now, the next part. Like I said, I didn't know that these were equal. I know they're equal, but I didn't know without a reason that they're equal, and that's the definition of an angle bisector. Okay, I knew that PQS must equal RQS if this really does bisect angle Q. Okay, so I knocked out that. So there's an angle, one of our angle congruence. So now we have an angle and another angle. Now, if only we knew the included side was equal. There's a way to tell, because look, this triangle shares a side with this triangle. Okay, triangle PQS shares a side with triangle RQS. Yay, that side must be equal in length, and that is stated by the reflexive property of congruence. Okay, it just says that if they share a side length, then they must have that same exact side length in common. So last but not least, I know that the triangles through the angle side angle postulate must be equal. That's the new postulate we're learning today. If we have an angle, an included side, and another angle, then they are congruent. So this is my congruent statement. If it asked me to prove that RS is congruent to SP, then I could just say they are congruent because of CP CTC. It doesn't say to do that, so we don't have to do that, but there's just an example if it asks you something different to prove. Okay, so there's your angle side angle proof. Just that's how you use it. If you have an angle and an included side and another angle. The rest of it is basically the same stuff we've been proving before, same steps. We're just with different information that's going to help us to prove it. Now, we've constructed a triangle using side, 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 and side, angle, side. Now let's do the same thing with angle, side, angle. So it's going to be a little different. So you're going to draw the triangle, whatever triangle you want to copy. And we're going to use this angle, side, angle postulate to construct. So now this time we're doing a little differently. So we're going to draw our line and we're going to mark our distance same way as before. And so then we have the bottom length AC is congruent to this little X to this little mark right here. Okay, and I'm going to have to copy my first angle. So I'm going to do a little arc right here and I'm going to see how far it is from here to here. And I'm going to make another arc. Boom, boom, and where they cross, that's where my next ray is going to go. All right, and then I'm going to construct another angle the same way. Similarly, I'm going to go ahead and go across, find how far that is right there, and make another little arc. Boom, boom. Okay, and wherever they cross, that's actually where it is. So you're going to construct an angle congruent to angle C at Z using XZ as a side of the angle. Label the point where the new sides of the angles meet as Y. Okay, so very similar to the side angle side, but not quite the same. So there is an actual instructional video on how to do that in a little more depth and with actual compass so you can see things. I think it's about 3 minutes long. It should be posted right underneath this video. That's all I have for you tonight. Once again, tomorrow, since this is kind of like a big section, I wanted to chop it into parts for you. For tomorrow, we're going to do a video in class. So you'll need headphones and things like that so you can come properly prepared to continue these notes tomorrow in class after your spatial reasoning and whiteboard warm-up. So that's it for today.